Statistical significance is a really difficult concept to understand. However, it's an even more difficult concept to explain intuitively. You're looking at the faces of some of the world's top meta-scientists. So these guys study the study of science. And they've just been asked, could you explain to me what statistical significance is in one sentence? And it turns out that that is really, really hard. If you're an analyst or a product manager and you've ever looked into what statistical significance is this one? You may have had the misfortune of coming across p-values. And if you're really, really unlucky, you may have come across a definition like this. Given the truth of the null hypothesis, the p-value is the probability of obtaining an effect at least as extreme as the one in your sample data. Great. Clear as mud, right? So how can we try and attempt to understand this? Well, let's use an example that you've probably heard hundreds of times when talking about online experimentation. You want to make a change to your website. In this case, you have a challenger and a control. The challenger is the change you want to make, and the control is the default of your website. So let's use the classic example. You want to change the color of a button, of course. In this case, our challenger is the red button, and the control is the blue. Why on earth would you want to make this change? Well, it all starts with a hypothesis. In this case, we believe that changing the button to red will improve conversion because, red is on brand. Why not? Okay. In scientific method, the burden of proof is on the challenger. So let me give an example. Say you are working in a pharmaceutical company and you've come up with a new pill and you say, my new pill is 100 times better than a placebo. We don't then say, okay, we're going to collect evidence to prove your claim. Instead, we say, much more conservative, we're going to try and find evidence to say that your pill is at least not different to the placebo. So we're trying to prove a different hypothesis, or rather trying to disprove a different hypothesis, the null hypothesis. So in this case, instead of changing the button will improve conversion, we go to changing the button to red will have no effect on conversion. Let's go back to our definition. Given the truth of the null hypothesis. So in this case, if we believe that blue and red are exactly the same, there's no difference. The p-value is the probability of obtaining an effect at least as extreme as the one in the sample data. So we need two more things, right? We need an effect and a p-value. We've run our test, red versus blue, and we've calculated the results. Okay, we've got an effect. It's an uplift of 1%, and we've got a p-value of 5%. Let's go back to our definition. What does that mean? Okay, we've got a 5% probability of obtaining an effect at least as big as the one we've seen here, given that there's no difference between the two of these. So what does that mean? Say we know for a fact that red and blue are completely identical. If we run this test 100 times, in 5 of those tests, we'd still expect to see an uplift at least as extreme as this. But that doesn't get you straight to statistical significance, right? Before you started the test, you had to come up with a threshold, a risk you're willing to take in accepting results that aren't really there before making decisions. Say you said that threshold was p equals 5, a 10% cutoff. Okay, we've reached statistical significance. Clear? Absolutely not. That's horrible. It's really clunky. If you understood that right off the bat, that's absolutely fantastic, but I'm not even sure I believe you. But I'm going back to the original problem statement. We've asked all of these people, explain it in one sentence. And admittedly, they were on the spot. I've had a little bit more time to think about this. And this is probably the best thing that I've come up with. Statistical significance tells us if there was no difference between the control and the challenger, we'd be unlikely to see an effect this large. Is it great? No, it's still pretty rubbish. It's still not that intuitive. But what you might notice is it doesn't actually tell us very much. In fact, statistical significance doesn't tell us the probability that this change will be positive. It doesn't tell us whether one statistically significant result is more statistically significant than another statistically significant result. It's just binary. It's either yes or no. It's either statistically significant or it's not. It's not more or less statistically significant. And it also doesn't tell us whether the change that is come out as statistically insignificant means that there's no effect. If something's statistically insignificant, we don't know. We just don't have enough data to make a conclusion. That's not the same as saying there is no effect. So based on this, you'd be pretty tempted, and forgivably so, to think statistically significant is pretty crap, it's pretty rubbish. And if you did that, you'd be in pretty good company. In recent years, there's been what is probably a revival in a revolution of saying statistical significance is terrible. Statistical significance is hurting science. And one of the main reasons for that is it's a very easy thing to manipulate, and it's also been seen as kind of an arbitrary gateway for getting scientific studies published. And in many of these studies published, certain steps have been taken with the data, or it's been played with in certain ways that means that that published research isn't reproducible, which is one of the key facets of science. Such is the extent of this criticism that the head, or the executive director rather, of the American Statistical Association has said, the p-value was never even intended to be a substitute for scientific reasoning. So knowing all this, why should any of you care at all about statistical significance? Well, to paraphrase Churchill, statistical significance is the worst way of deciding something better apart from all the others. So going forward, what can you do tomorrow in work? How can you improve how you use statistical significance? Well, I bet you've heard some of these before, but let's go through them. You've got to wait until you have the correct sample size to make a call. That's really important in controlling your error rate there. Another element to this, if you run a test and you want to split it up into multiple segments, you're going to get a lot of noise in there. Make sure you have a really good hypothesis of why you might be seeing a certain effect if you see it statistically significant. Take any statistically significant effects with a huge pinch of salt if you can't explain before the test why they might happen. Number 3, say you've got this statistically significant effect. Look to back it up with secondary metrics. An example of this, say you've got a statistically significant result on conversion. Have you changed bounce rate at all? Can you confirm it in other ways? Number 4, and the strongest by far out of all of these, if you're uncertain of a result or you want greater clarity to make sure that result is actually changing something underneath, just retest it. That's a really strong way of confirming results. Now, a minute ago, I said that statistical significance is the best out of a bad lot. That's not always necessarily true. As Andrew said at the beginning, there's also Bayesian inference, which can be seen as an alternative to statistical significance, which, under certain circumstances and if certain assumptions are met, can avoid some of the pitfalls I've mentioned here. But that is definitely another at least 10-minute talk. Thanks very much. Happy to take any questions.